Welcome everybody. Today we're going to be continuing our discussion of Pal World. We've got green Pal balls. We've got... No, actually we're doing inheritance still. Sorry. You want to talk about Pal World? Well, the devs just apologized for fixing a bug, which was absolutely hilarious. There's a bug in the game where you can capture the bosses in a Pal ball, and they fixed it, and then people were like kind of upset that because it was, you know, a thing. It was a glitch that people loved, and so they apologized for fixing the glitch, which is top tier. Okay. So no, we're going to be talking more about inheritance today. We're specifically going to be talking about something called dynamic casting. And this is, pull this over here. This is a way that you can cast between different objects in a hierarchy. So one of the problems you're probably encountering with your linked list assignment is your merge function. One side note on merge, the STL version of merge is not what we call merge here. When I think of merge, I think of taking all the objects in data structure A, all the objects in data structure B, and mushing them together. That's merge, right? In the standard template library, the merge is what I would call a sorted merge. So STD merge. It is a sorted merge. So it merges other to this. Both lists must be sorted. So if you have a list containing 10, 20, 30, 40, and 15, 25, 35, 45, then it'll go 10, 15, 20, 25, 35, 40, 45. It will zipper merge them together like cars are supposed to do on the street, but don't. So be careful with that, because if you just call the list merge function, it's not going to be correct, because for whatever reason they named what I would call sorted merge, and what they call splice is what we call merge. So just be cautious of those terminology differences. But let's say you're trying to merge two different lists together, and your base class for the homework assignment is going to be like the WLL base class, and then you're going to specialize it. You're going to have subclasses off of it for your implementation, for the STL implementation, for the ChatGPT implementation. And the reason why we do this, the reason why this works so nicely, is so that you can very quickly just substitute out one of the implementations of a doubly linked list with another one. The base, the pure virtual base class just has equals 0 for a bunch of things. You know, insert and delete and all this kind of stuff. It's all equals 0. It just says, hey, anybody who overloads me must implement these functions, which is a great way of doing what's called an interface in other languages. And then basically you can have 3 different people write 3 different implementations of the doubly linked list class, and then just use pointers and just stick them in. So if you guys need a reminder of what that looks like, cd milestone to .cc unique, like this. So WL is the base class, and it doesn't have anything. You can't actually make a variable of type WLL. If we try making a WLL named Bob, it is going to be mad at us because it is an abstract class. You cannot have a variable of type WLL. There's nothing in it. It is just it's a promise that all of the children are going to implement this list of functions. And the reason why we do that is because then when we do make unique WSTL, WLL, WGPT, then those functions that you write just get slotted in where the interface had an equals 0. And then down here, you don't have to have this copied and pasted 3 times. If I'm doing the ChatGPT version, then call ChatGPT list functions. If I'm doing the STL version, then call STL functions. Now, the only place where any of this code is different is right here. That's it. The only place where main is different, based on the 3 different implementations, is when it's literally selecting which of the 3 implementations it wants. It's a very nice, very clean design, but it does present a challenge. It presents a challenge because when you are trying to merge 2 different lists, you need to know if the other list is the same type of list that you are, and that's a problem. So like over here, over here in WLL dot H dot H, not slash H. You'll see here that it's taking in another WLL like that, right? And if you look at the WSTL, the merge also takes in a WLL. It's not taking another WSTL, which is, you know, what you might think it should take. It has to take in a WLL so that it can override the base on it. But this presents a problem because you want to merge two different WSTLs together, but a WLL is not a WSTL. So let me show you what that looks like. Let me show you what that problem looks like over here. So I've got here, I'm going back to my animal example just because it's the law. Anytime you do inheritance, you have to talk about it in terms of animals, even though you wouldn't actually write code this way probably most of the time. So we've got here an animal base class, and this is pure virtual now because I've added an equals 0 here. You cannot make a variable of type animal. If I tried making a variable of type animal, it would yell at me. If I say animal A like that, it's going to yell at me. You can't do that. It's an abstract class because this is a pure function right here, pure virtual function. Okay. Pure virtual, sometimes called. Okay, so the trouble is if we want to merge two different animals together, right? Like let's say that we want to merge a lion. Ada, how do you make a chimera? A lion, scorpion,
ram,
and a ram. Okay. Or a hippogriff. What's a hippogriff? And a griffin? Hippogriff and a griffin are different. Hippogriff is
like,
it's like a lion's head on a griffin body.
No, well, it can be.
A griffin's like a hawk and a.
No, a griffin's also like an eagle head on a lion body. Eagle thing.
Griffin versus hippogriff.
And hippogriff is like an eagle in the front half and like back.
I see. Okay.
See.
Yeah, my daughter knowledge checked me on this. By the way, we were coming back from Strategicon, and she had the D&D monster manual in the back seat, and I'm like, I think a griffin has the head of a lion. She's like, no, it has the head of an eagle, and she actually successfully knowledge checked me on D&D lore. Hippogriffs are horse and eagle. Griffins are lion and eagle. Okay. Okay, girl. Yeah, you're right. Okay, so we're gonna merge two different animals together. Okay. Now, here's the thing. Here's the problem. All right. Let's say we want to merge two different. Pull this part out here. Let's say that we want to merge two different walking animals together. And so when you merge together a horse and a cow, you end up getting an animal that has 8 legs, right? Because you've merged a horse cow together. And so all the legs come over. And so the number of legs I have gets the number of animal legs the other guy has, and they get merged together into one creature. Okay. But there's a problem with this. The problem is animals, because I am taking an animal pointer, animals don't have legs. Only walking animals have legs. And so if I made this function take a walking animal, the code, let's get other here. If I made this a walking animal, that's fine, except now I'm not actually overriding the virtual guy and animal. And we got a problem down here. These guys are still pure virtual because we didn't override the function that was virtual. So that's a problem. But if we do take an animal pointer, then the animal pointer isn't going to have legs. But we're only going to merge two different walking animals together. We're not going to maybe we can figure out something in the future. But for now, let's just assume that if you merge one walking animal, it'll take another walking animal. And so with what knowledge we have right now, there's no way of resolving this problem. Okay. And so what the new thing that I'm going to teach you right now is a function called dynamic cast. So dynamic cast will allow us to convert one pointer type or one reference type into another reference type or pointer type that's in the same class hierarchy. Okay. So if we take in an animal pointer and we try dynamic casting this to a walk pointer, let's say walk pointer temp equals dynamic cast walk pointer. Now it works. Okay, so we can pass a walking pointer to a function that takes an animal pointer, and then we can dynamic cast it to a walking pointer and then add its legs to us. And this will work fine as long as what we passed in was actually a walking creature. Okay, so let's go down here. Not anymore. Let's go down to the bottom of the file, and let's say that we got a walking creature called Nina, and then we've got another walking creature called Alexander. Okay, and Alexander, being a dog, has 4 legs. Right? And we want to merge Nina and Alexander together to form a chimera. Right? So we say Nina dot merge Alexander, and then and we have to pass in a pointer. It doesn't work with regular variables. You always have to work with pointers when you do inheritance, which is one of the problems with inheritance. Is you always have to be working either with a pointer type or a reference type. Oni-chan? Yeah, so if we then see out how many legs Nina has now, it should be 6, right? Because she has 2 by default, and then we merge the dog with her, and now we're going to have a 6-legged chimera.
Okay.
What?
What? You merged a girl with a
Wait, we have 8 legs. What's going on here? Huh? What?
Dog has 4 legs.
Dog has 4 legs. Yeah, but what's going on here? Oh, we default to 4 legs. Okay. So, let's... I was like, yeah, you can't have 8 legs. That's just a spider now. That's just wrong, you know? So Nina's legs should be set to 2. Alexander can keep the default number 4. Okay, so when we merge Nina and Alexander, we now have a 6-legged monstrosity. You guys understand? Yeah, there we go. So it's an insect, not a spider. So, so for those of you that don't get the reference, it's from one of the most famous scenes in Full Metal Alchemist. Let's see if I have the. It was one of the episodes that I skipped when we watched it together. It's too disturbing. Yeah, there's this delightful little girl, and the father Tucker merges his daughter with the dog, and this is what it looks like after his grown. Edward Oni-chan. You're welcome for that, Ada. And that's why we skipped that episode.
Why did he do that exactly?
Why did he do it? He was trying to practice how to make chimeras, I guess, and so he practiced on his own daughter, which is kind of messed up. Ada, I would never do that to you. I'd practice on somebody else's daughter. Okay.
Yay!
Thank you. That was in both Brotherhood and the original. Yeah. So Full Metal Alchemist, one of the greatest animes of all time, in my opinion. Okay. So that's the reference there. So we're gonna merge in Alexander, and then we got 6 legs. Okay, cool. But here's a problem, right? So we're dynamic casting. We're doing a dynamic cast, and so we're gonna assume that we're only gonna merge a walking creature and a walking creature together. But what happens if it's not a walking creature? What if it's a bird and the bird's, or a snake or something like that, right? Snakes, let's make a snake class. I don't know. So struct snake inherits from animal. And snakes don't have legs at all. I don't know. We'll give them a speak or something like that. So I'll give them a speak and say, Ada, what sound does a snake make? There's somebody walking her dog on our sidewalk. Ada, there's somebody walking their dog on our sidewalk. Go out to the front door. So, okay. So what if we tried making a snake and merging a snake with Nina as well, right? So if we try doing that, we're gonna probably end up with a problem, right? What is the Harry Potter Parseltongue? All right. So what sound does a snake make? Let's Start making noises, hissing and spitting. Okay. Yeah, we'll go with that works for me. Okay, so we're gonna make a snake. What was the name of the snake? What was Voldemort's snake called? Like Nagini or something like that? Nigiri? No, is that sushi? What is it? Is it Nagini?
We don't have a
Nagini.
neighborhood watch in our because a couple of houses in our she told me that a couple of houses in our neighborhood have been broken into, so it's for a meeting on the 21st.
We got a security system in case you guys are wondering.
To discuss about the neighborhood.
Yeah,
watch.
it's probably a good idea. I'm always watching my neighborhood. Okay, so what's the problem with this snake? Oh, because we have to override merge, right? So we want to try merging two snakes together. I don't know. Don't do anything. Whatever. Simple. Easy. Function definitions not allowed here. Merge. Override. Oh, I got the close brace there. Okay. Virtual void. Speak.
Oh, did you know that the points in Minecraft
There.
you know how you gain points in a
Yeah,
bubble?
missing bracket. Very good. Started
You
around.
can actually use it to read. Oh.
So if we have Nagini, what's another name of a snake? What's your favorite snake?
Lily used to have a snake, and his name is Waffles. He was a cute little butter yellow and white snake. Butter yellow and cream.
How about the rolled snake? Jormungand. You like that one, girl? The rolled snake? The Midgard serpent? You like that one, Ada? Okay, so if we are to merge Jormungandr and Nagini together, no problem, right? Because the function doesn't do anything. Right? That's fine. We can merge two snakes together. It's fine. But what if we tried merging Nina with Waffles? You have a snake called Waffles.
No, Lily does. It's a cute yellow and white snake, and she showed me.
Is it poisonous?
No, it was made for.
All right. So who should? Okay, let's take a vote on Discord.
It was a cute picture with it sticking out its tongue. It was absolutely.
Okay. So we've got a cute snake named Waffles. We've got Voldemort's evil snake named Nagini, and we have the Viking Midgard serpent that encircles the world that will bring about Ragnarok. So Nina, we're gonna buff her up a little bit. Right now, she's just kind of a worthless dog. So who should we merge Nina with? You guys tell me. Should we let's take a vote. Okay, do we want good snake, evil snake, or big snake? Put your votes in now. Snake from God of War. Big snake. All right, Nina's gonna get buffed. Okay. Jormungandr, boom. All right. So now we need to make that a pointer also. Okay. So we got a problem here though. We're gonna be up here. We're gonna be in the walk merge function, and we just got a pointer to an animal, Jormungandr. So that's fine. The type system is perfectly happy with us. But now we're going to be converting Jormungandr to a walker, a creature that has legs. And Jormungandr does not have legs. And then we're going to be adding its legs to Nina. And you might say, well, it'll just be 0, right? Like it doesn't have any legs, it's 0. No, wrong. This variable only exists on walking creatures. Snakes do not have a legs variable. It's not like they have a legs variable that's 0. They don't have a legs variable at all. And so it is impossible to access its legs variable. So anyone want to take a guess? What will happen if we try converting a world serpent to a creature with legs, like a dog or a cat or a human?
It's a lizard.
It's a lizard now.
It's quite literally a lizard.
Like I said, my wife got in trouble during elementary school because she said that snakes were just legless lizards.
But they literally are. I'm gonna get in trouble for this.
No compiler error. And this is one of the reasons why I have to be very careful with dynamic cast. Is that if you cast something to something that it's not, then it'll just well, let's find out. Anyone else? So Surin is voting for segfault. So we got 1 vote for segfault, one vote for compiler error. Any other votes? Anyone take a guess? Sokolov? What you got for me? Integer overflow? Error? Segfault? Okay. Let's try it. Segmentation, fault, and core dump. Very good. And the reason why we got a segfault was because this actually returns a null pointer. So if you try casting something to something it's not, if you don't make me who I'm not, I just want to. Is that like the teenager line? Don't try and change me. Try and make me somebody I'm not. Yeah, it returns a null pointer. So we can simply say if temp equals null pointer, then we can just handle it. We just be like, scout, hey, don't try merging a non-walker onto a walker. And just return. We can handle it gracefully. And then when we try doing this, it'll just, oh, no, you tried. Sorry. And then your program just continues on with its life. Maybe you log it. You log it to a log file or something like that. That's fine. If you want to be a little bit more harsh, how many people here are familiar with assert? So that line right there. Assert is pretty common. If you've ever played a Bethesda game, I'm sure you've had your Bethesda game crash with an assertion failed error. 0. And it pops up a little dialog box about that big. Assertion failed 0. And then it quits your program. Which, again, that's usually why we try, handling it gracefully. Like, oh, you tried converting something that's not right. Yeah, just put in a log file, and look it up later and find out where you went wrong, with your life. So assert is the official version of, it's in the standard library. It's the official version of our die function. So you guys always remember what I say when you get bad input? Die, like Reaper, right? That's a little function that I wrote. And the reason why I wrote that function, it just prints out bad input and quits, is so that the input tester will pick it up, right? So if I type in squirrel or the Declaration of Independence when it's expecting a number, then your code just prints out bad input and quits. And that's so that my test cases will be like, okay, they found that error, Assert is the standard library version of die, okay? So watch what happens here. A.out, main.cc, line 32, virtual void walk, : merge, animal pointer, assertion temp failed. Boom. So it's a better version of die. Now the reason why we don't use assert is because you're going to die on a different line every time. You know what I mean? And so I just have it print bad input instead, so that the input and the output match, right? In other words, when you die and my program dies, they just both print bad input and your output matches mine. Whereas if we used assert, you would die on line 32, I would die on line 36. They're not the same line, and then you would fail the test case. So that's why we don't use assert in our programming assignments. But in real life, it's more useful. It's better than die because it tells you the name of the executable, the name of the file you're within, what line you're on, the name of the function, and why it died. Okay, assertion temp failed. So when you say assertion temp, when you say assert temp, this is like saying if temp equals 0, die. Okay, so assert means assert that it's true. I'm asserting this thing must be true. And if it's true, it just goes on with its life. If it's not true, then it kills the program and says, on this line, on line 33 now, on line 33, it failed because temp's supposed to be true and temp was false. False is a null pointer, same thing. And boom, that's your mistake. And then you can open up the file, you go, oh, the dynamic cast failed. And you can figure it out from there. You guys understand? Assert's real stuff. Real talk. You guys like it? Understand it? All right. The other nice thing about assert is that if you compile your code, I think with, I haven't tested this actually. I'd have to look it up. There's a way that you can actually turn off all your asserts. So just with one hashtag define, basically, you can it's debug equals 0. I don't know. There's some hashtag define you can give, and all of the asserts turn off. And that's nice because once you're pretty confident that none of them are getting triggered, then all of those if statements you're just doing for no benefit, right? Like you're just constantly saying if this, if this, if this, if this. Another thing like that would be very common is like every time you get a pointer, right? Anytime you get a pointer, it's very common in professional code to say assert the pointer, right? Which assert the pointer. And that means if the pointer is null, die, right? Don't try and merge me with a null pointer. You know what I mean? If you pass in a null pointer here, you did something wrong, right? And so this is very common. Anytime a pointer should never be null, it's very common for the very first line of the code to be assert the pointer. In other words, make sure the pointer is true. In other words, make sure the pointer is not 0. In other words, make sure the pointer is not null. Very common in code. And then once you've tested your code and everything's like, you know, working, you're happy with it, and you need the speed. I would normally just leave this in, you know what I mean? But like if you need the speed, then with one hashtag define, you can turn off all of your asserts and your code speeds up. Nice. Okay. So that's you know, I could show you how to do this manually. If and def release. So now, if I define release, that's like that there, this dash D release. That's like inside of my code, I'd say hashtag define release, like that. Okay. So it inserts that hashtag define release into your code, essentially. Okay. So now if we run this, we, if not defined. If def do assert, let's just do it this way. It's like overriding my if def. Well, whatever. I'll have to look up the exact hashtag define to turn it off. That's weird though. Huh. Okay. So what would happen? Okay, so we obviously can't merge Nina with a stink. Okay, so that's going to cause problems because Nina can only be merged with something with legs. But what if I tried merging Nina and Batman together? Okay. So Batman is of type bat, right? Bat is a walker and a flyer. I just did this before class right now. And so the walker flyer class inherits from both walk and fly. I've made this like complicated class hierarchy. So bat is a walker flyer because it can both walk on the ground and it can fly with its wings. Birds can only fly. They can't walk for, I don't know, whatever reason. They don't have legs apparently in this world. Cats can only walk, birds can only fly, bats can both walk and fly. I don't know, it doesn't make sense, don't ask me. So Batman inherits from Walker Flyer. Walker Flyer inherits from walk and fly. So bats have legs. Okay, so bats have legs, all right? But they're not exactly the walker type. They're not the walk type. They're they inherit from Walker, they inherit from Walker Flyer, and then they're bat. So they're like 3 levels below walk on the class hierarchy if you sketch out the conspiracy theory diagram for what we got going on here. So do you guys think this will work? Can I cast a Walker Flyer to a walk? Could you just have had bat inherit directly from walk and fly? I could have. But the reason why I didn't want to do that is because both walk and fly override speak. And so by merging them together like this, I don't need to have a speak function on every single child. So we have the diamond inheritance problem. And so both walk and fly override speak. So if you inherit off both of them, then you're going to have two speak functions. And so you have to override it. And so by putting a walker flyer class there and having a speak there, I don't have to override speak and merge on every one of the children classes. So I would have to override everything because otherwise it wouldn't know which of the two to use. So by merging them together like that, it simplifies all the children class that inherit from both of them. But yeah, I could have. It just would have meant everybody would have had to speak and merge, which I think they do anyway. So, but I don't have to. Like if I have here, I am the darkness. Yeah, I could get rid of that. It would still work. Okay. I can get rid of that. It'd still work. Okay. All right. So what do you guys think? Can I merge Nina and Batman together? Batman has legs. Nina has legs. Nina is up to 6 legs at this point. She's sitting pretty. But we're trying to merge Batman in with Nina now. So is that going to work, or is it gonna segfault? Or I think we have an assert in here now. Yeah. Oh, that's why, because I have another assert right here. I am smart. If def debug. How about this? Do the assert. And if. There we go. Now let's see if this works now. Okay. So it works. Okay. But if we try this with Jormungand, then the assert we're actually just right. So by turning off the assert, it won't die. Okay. So yeah. So with hashtag defines and things like that, you can turn blocks of code on. You can turn blocks of code off. So you can say like if def Bob, do all that, and if, and then you can either in your code you can just say define Bob, and then it'll put that code in. If you take that line out, it'll take that block of code. This code will get literally surgically removed from your source code. It doesn't appear at all. The preprocessor can do things that C++ can't do. It's better than an if statement. It just actually cuts that code out of your code. And then in your compile, at your compile level, you can define Bob like this, and then the code gets put back in. But if we don't define Bob, then we segfault. Okay. So this is very, very commonly used in computer science. We very commonly use hashtag defines and things like that to turn on blocks of code, turn off blocks of code. Oftentimes when we have differences in operating systems. So we say if def, if we're on Linux, do this thing. Else if we're on Mac, do this thing. Else we're on, PC, do this thing. Right? And so you can have the exact same source code that will switch out like maybe, how you open a file or how you, draw a window or something like that. You can actually have your code be the same code, same function, does everything the same, but have platform-specific differences using if-defs and things like that. So let me just put this back the way that it should be. That's some real talk right there. That's literally like, how professional programmers do things. You can say, if I'm on Mac, run this code. If I'm on Windows, run this code instead. And then just when you recompile it on the different system, it'll just switch the functions out. It's kind of cool. There is a legs variable that should be able to merge correct. So you can cast a child of walk to walk. That's fine. Because anybody who is a child of walk, which includes walker flyer, cat, anybody who's a child of walk can be dynamic casted to walk because all of them have legs, right? And so we can grab the number of legs off of Batman, merge it in, And let's turn off the bad merge here. And then if we see out how many legs we have now, Batman, of course, has 2 legs. So if we see out Nina.legs, girlfriend not found. Okay, there we go. Now we have 8 legs, right? So that is how you guys should be doing your merge function. Not full Metal Alchemist style, right? But for your merge function for your linked list class, basically dynamic cast it to whatever type you are. So if you're doing the WSTL, you're never going to encounter anybody that's a doubly list that's not a WSTL. So you just probably safely just dynamic cast to WSTL, and I'd probably throw the check in. I'd probably throw a check for null pointer, right? Just to make sure, it works, right? It's always a good idea to check for errors and things like that. But you should be pretty safe, because in main, if you were doing WSTL, everything's WSTL. Nothing's not WSTL. And if you're doing GPT, everything's going to be GPT. So you probably get away without that check, but you should probably put the check in anyway, just in case. Okay. So is mergeability determined by sharing all member variables or by sharing the ones that you're using in the merge function? Yeah, it doesn't matter if we use the legs or not. Like this doesn't matter, right? Because the dynamic cast fails on the dynamic cast line. It fails when you are not a child of the pointer type. So our pointer, we're trying to cast it to a walk pointer. If we are elsewhere in the class hierarchy, if we're not descended from the walk class at all, it'll fail and give you a null pointer. But once you've casted it to a walk pointer, then you know it has the legs on it, right? Because legs is part of the walk class, right? If I scroll up a little bit, right? Once you've casted it to the walk class, you know it's got legs, because it's part of the class right there. Now you don't know if they're going to have wings, right? I can't use wings here because walkers don't have wings, right? So lose always on top here. Weird. Always on top's broken now. Whatever. You don't need to see my face right now. Yeah, so that's about it for dynamic cast. You can cast things sideways sometimes, but generally speaking, you use dynamic cast when you know that the thing getting passed in is not actually the base pointer. You take a function that takes the base pointer. Like here, we're taking an animal pointer, right? Because we have to. Because we're overriding the pure abstract class. And you want to downcast it to a child class. And you know probably this thing is going to be a walk pointer. All of this is kind of... all of this is really the result of people who like inheritance being afraid of if statements. Like literally, like the problem is, you could, instead of all of this stuff, right? Like instead of all of this class hierarchy stuff, right? You could do something like this, right? You could just say like, string class name equals walker. You know what I mean? Like you could actually just have a string that just holds what your class is, and then you can have an if statement. Like if I'm a walker, then access, the legs variable, right? Like you could, and everybody can have legs, everybody can have wings, but based on your class type, you use some of the member variables, you don't use some of the other. Now you might say like, well, putting everything into one class is wasteful of RAM and things like that, and it is. You just put literally all of the things you need ever into one actor class or something like that, and then just based on what your class name is, you use some of the member variables, you don't use other ones. At the same time, memory is cheap. And when everybody is one type, everybody's just an animal, then you can just make a vector of animals. You don't have to have a vector of animal pointers. And then if you want to find out what class each one of the animals is, you can be like, okay, well, let's grab its class name variable. Oh, I am a bat. Okay, great. And then you can do bat-like stuff. And this is nice because when you're given an animal pointer, you can't really tell what type it is. Like if you have a shoot function, right, and let's say you want bats to do double damage to cats because they rhyme, right? There's no, you can't say if the person I'm hitting is a cat because everything just takes an animal pointer, right? Everything takes animal pointers. And so, how do you say if this animal pointer is a cat? Well, you can try downcasting it. Like you can try dynamic casting it to a cat. And if it works, oh, it's a cat, but all of that is just a huge roundabout, ad hoc sort of attempt to just get away from writing an if statement. Like, who are you? I'm a bat. Look, it's right there. You can just ask it. Like, you have a member variable. It's called a tag variable. You just ask it, who are you? Like, I'm a bat. And so a lot of times people will put this in anyway. So the bat class will say, I'm a bat. The cat class will have a class name variable, I'm a cat. And then if you ever just need to know what the type of the person you're fighting is, you can do that. People that are inheritance purists will be screaming in horror right now at that notion. You just have something like this. And then, your snake constructor, you just say name is snake. Like that. Plastic. Something like that, right? So you can have every one of the member classes just set a variable name saying the name of the class. And inheritance purists hate that because, what's the point of having an inheritance if you're just writing down what your class is anyway? But it does actually make things easier when you do something like this, right? Like down here in here, we can just be like, if other points to name equals Walker, something like that, you can actually ask it what class you are, but then it gets complicated because what if you override that and you have a snake class? You have to say if the other name is snake or something like that, and it can get annoying. So there's no really great answer here, but a lot of times, yeah, if you just want cats to do double damage to bats, you just give it a class name and have at it, so you can write if statements like this. But the like I said, inheritance purists want the language to do the if statement for you, essentially. So when we do the dynamic cast there, under the hood it's saying, are you actually a walker? If you are, return a pointer. If not, return a null pointer. And so they want the type system to do all the heavy lifting for them for the if statements and things like that. And then it gets really complicated when you're like, okay, well, how do I do damage? How do I have cats do double damage to bats? How do I do this? And then you have, because it rhymes, Ada, because it rhymes. That's why. So, right. What's Bjarne's view? I don't know, man. There's something called double dispatch where you end up writing a function for every combination of damage, right? So bats attacking cats get one function, and cats attacking cats get another function, and bats attacking bats get another function. And I don't want to write that, man. I don't want to write 100 different functions for 10 different types of animals. In my video games, I got a lot more than 10 different types. I don't want to write n squared functions. Hell no. I just want the, a table, a table of multipliers, like the type system in Pokemon. Just give me a 2D table, or something like that. You know what I mean? Man, Putty is on. Putty's the name of the terminal you always see me use there. Right. So a lot of people, if they were doing Pokemon, they would implement each of these types as their own subclass. And I wouldn't. Like honestly, I would just make type a member variable, you know, and then you could just be like, if the other person dot type equals dark, and my type is, ice. I don't know. You know what I mean? Like then you just look it up on a table. And so there's a very long, very old academic and philosophical debate over the value of inheritance, whether or not you should use it, when you should use it. Should you have psychic Pokemon be a different type than ice Pokemon? Some people would say yes. Some people would say no. I personally would not.
Would it be the same thing as it?
Because all Pokemon are just Pokemon, right? And then you can just have a variable for my first type and my second type. But some people might be like, oh no, double inheritance, inherit off the ice type and the ghost type, and now you're a ghost ice Pokemon, Some people do it that way. Like I said, it's my personal take on it though, is, and you can see this in the guideline support, in the CPP core guidelines. So if you're ever curious about these philosophical questions and like which way the people who are experts in C++ think you should be writing C++ code, there's this thing called the C++ core guidelines, which I will post on here. And they have like philosophy on like, different things, right? You should express intent, instead of, programs should be statically type safe. Don't optimize without any reasons. Don't optimize prematurely. These are things I lecture on. Use compact data structures, and then some of them are just kind of missing data on them. But they've got some really good stuff in here. And so the CPP core guidelines is just full of like advice from experienced people on like, should I do it this way or should I do it this way? And there is something called favor composition over inheritance, which is something I believe in. Composition over inheritance. I think it's in the core guidelines. I think it's in there somewhere. Anyway, so the notion of here's a class hierarchy, right? And like some people write code this way, and more power to them. But like everybody who's turkey-like has a gobble function. Everybody who's duck-like has something quackable can, and these things override the quack interface, like red-headed duck and all these, so. Oh no, this is composition. I see. So they're kind of I see. Yeah, how they're doing it. So what they like doing is using member variables instead of inheritance, right? So instead of using inheritance, like you see here, visible inherits from object, solid inherits from object, movable. Instead, you can have everybody's got a visibility delegate, a update delegate, a collision delegate, and things like that. And so, so you basically build a class by connecting components together versus inheriting off all these different things. So, it's just like I said, it's one of these big debates that has been raging since the 80s. People who love object-oriented programming typically love inheritance. Not all of them, not by any stretch of the imagination. But there's like people who like Java, for example, are just used to thinking in terms of objects and inheritance, and that's just natural to them as breathing. Yeah, it's gonna be a no for me, dog. Yeah. Other people, don't like inheritance at all. And just make one class that does everything, and then their if statements can get quite large as a result of it. There's no magic bullet, for any of this stuff, and so it's always just it's just something that when you're designing your project, and it's something you're going to have to get experience at too. Sometimes inheritance is just a really good match for the problem. Like with our doubly linked list things, it's just perfect. Like you could just slot in the GPT version, you can slot in your version, you can slot in the standard library version, and that's it. 3 lines of code, and you've got 3 different versions of your main without having to change anything else. It's great. And then there are times where you're like, do I really need a flyable thing to inherit on? Or could I just have a Boolean called can fly? You know what I mean? Like, do I really need another class to inherit off of? And then that'll make all my dynamic casting more complicated because I got to worry about, do I have this class or do I have this class? I could just add a Boolean called can fly, a Boolean called can walk, a Boolean called can crawl, can swim. And then every actor will just have true or false, whether it can engage in those forms of motion. You know, it's something, you know, I wish I had a good answer for you, but the answer is there is no answer. It's something. Okay. All right, Nina, that's enough. Let's switch this back. Sounds nice. Sounds nice too. Oh. So, it's something you're gonna have to decide for yourself over the years. I used to go very hard into inheritance, and I just kept running into problems with it. You know, like, oh, do I dynamic cast this way or that way? And yeah, like a lot of times it's just easier just to fine. Every actor knows whether or not they can fly. It's 1 bit of RAM, 1 byte of RAM, 1 word of RAM. Who cares? You know, per actor, who cares? I don't care. You know, and there are people that'll say, well, you know, an actor shouldn't know if it could fly or not because then it has to know something about flying. It's like, all right, fair enough. It could default to 0. It could default to false. You know what I mean? Like, you just have all these options off by default, and then when you make a Batman, it could fly and walk. And you don't have to have a separate class for it and a separate implementation file. And yeah, making big computer science projects and systems is complicated. And you know, at some point, somebody's got to actually do the work. At some point in your code, you're going to have the ability for a bat to do double damage to a cat somehow, somewhere. And how you organize that and keep it maintainable and future-proof it and allow for new classes to be added without breaking all the old ones, that's part of the fun of computer science. It's fun in the sense that Ada used to think the word fun meant, right, Ada? Ada, is going to the park fun? But my memory, yeah. I got 64 gigs of RAM on here, man. Like an extra byte per actor in my world is not. That's not what's eating up my RAM. What's eating up my RAM is, you know, the 20 gigs of uncompressed audio, you know, preloaded, you know, to increase the frame rate by 1 frame per second, things like that. Yeah, and inheritance also, the V table takes up space. I don't even know if it helps in the end. All right, so that's it. I think we're done with inheritance now. So you guys got till Friday to finish off your projects. If any of your classmates have turned into ghosts on you, send me a message. I can remove them from the group or give them a 0 or something like that if they're not helping. So you know, you're still gonna have to do the work, but you know, talk to me and let me know. Okay. Stacks and queues on Friday. Yep. All right, so that's it for today, guys. Thanks a lot. Peace.